Welcome to another interesting episode along the course of your preparation for UTME 2023. In the course of today's class, we're going to be looking at certain dynamics as to what your level of preparedness is as far as your forthcoming exam is concerned. So here is it. We said we have a specific number of branches as far as physics is concerned. Physics being the subject, mechanics, heat and temperature, waves with respect to optics and sound, electricity alongside magnetism, as well as atomic and nuclear physics, being the key branches we are going to focus on. We want to now examine certain level of preparedness we've been able to garner over the course of the months. These 5 aspects, the branches which we have under physics, we're going to be highlighting four questions each, for which we tend to see, okay, you as the student attempting it, then we tend to evaluate the answers together. With this, you can place yourself on a score sheet as to what your level of preparedness is as far as various categories of branches are involved. So you can easily evaluate yourself. Did I perform very well, better in mechanics as compared to heat and temperature? Did I perform better in waves as compared to electricity and magnetism, or whichever way it goes? So quickly, let's get into the business of today. Mechanics aspect now. Yeah, 4 questions straight up. We're going to look at 20 from this instance. We are picking 4 each. Try look at what your momentum would be and how fast you are going to be in terms of answering the following questions. Remember, 40 seconds you have for each question in Jamb. So, look at the first one. See if you have an idea as to what the question entails. The question is this. So, which principle do we have associated with this? Quickly write your answer. The next one coming up. So here is the question. Just a single line answer you have to provide. Remember, it is to self-evaluate your readiness with regards to topics under mechanics, which you have read so far. It's not just the job to carry out, which entails just reading. There should always be a time for self-evaluation to see what your level of preparedness is in terms of the questions that will be thrown at you in your examination. So the second question coming up is this. What is actually the relationship between kinetic energy before collision and that after collision, after an inelastic collision? Remember, we said that there are 2 types of collision, elastic collision and inelastic collision, all guided by momentum of 2 bodies involved. Now, in the concept of talking about elastic collision, there were certain things we discussed which are paramount to consider, similar as we would have under inelastic collision. And those 2 key aspects will be centered on picking your momentum before collision and the momentum after collision, as well as picking kinetic energy before collision and picking the kinetic energy after collision. So, I'm sure you've written the answer. We move up. The next one, still under the scope of mechanics, which you've been reading all along. So quickly write your answer. We'll get to look at the correction overall, but we want to evaluate to see to what extent we can deliver on the answer. The question is asking you, what is the formula for frictional force in an inclined plane? Remember, we have the equations of motion, which is answered under kinematics. Anytime you are making reference to friction, frictional force, as the case is, the calculations under it are subject matter of dynamics. And dynamics, we say, is actually the branch of physics that considers motion of a body and the force causing that motion. So we take into account what force is bringing about such type of motion under dynamics. So we have frictional force under the scope of dynamics. You are being asked, imagine you're being asked to calculate something involving frictional force. Are you able to differentiate clearly what frictional force on an horizontal plane, smooth surface, would entail, and that from an horizontal what? Rough surface as compared to what? Horizontal inclined surface, as the case is. So this is question 3 for you. On the list of questions, you can always project this as the last one under mechanics. We have this, number 4. Number 4 question. We proceed. So there you have it. What is actually the velocity ratio? What is the formula for velocity ratio for an inclined plane? For an inclined plane. So quickly, I'll give you 1 to 2 minutes to actually brush up on your answers. Remember, these questions are kind of direct, one-way answer, just one-line answer. You read, you just write the answer in front of it. You read, you write the answer in front of it. So, tick-tock, tick-tock, tick-tock. 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 Give it your best effort. 40 seconds is all you need to answer your physics questions after reading the questions once or twice. Only 40 seconds as estimated in the course of 2 hours. So, let's have it. Great. At this instance, I would expect that we should look at the solutions together. So, here we go. Which principle is actually associated with the formula F1 over A1 is equal to F2 over A2? You would agree with me, force over area is spelling out pressure. It is actually the formula which represents pressure. As such, this is linked with something involving pressure. And among all the principles you have associated with pressure, you would understand that we have Archimedes' principle, we have the law of flotation or buoyancy, and we have Pascal's principle. Archimedes' principle has nothing to do with F over A, in the sense that it states that what? When a body is actually partially or wholly, fully immersed in a liquid, it experiences what? An upthrust, which is equal to the weight of the what? Liquid displaced. When it comes to the law of flotation, we said that what? A body will float when it displaces its own weight in the liquid in which it is what? Immersed. So that is law of flotation. Only Pascal's principle says that what? The pressure in an enclosed liquid is actually what? Distributed evenly across what? All parts of the liquid and across the wall of the container. And this involves the principle of the what? Hydraulic press. So this guy is actually answering Pascal's principle. So just in case you don't know your principles quite well, then it is time for you to go over it again. Pascal's principle. You can go ahead to mark it. Evaluate yourself. Now, here is the catch. As much as possible, you want to try to actually tick yourself correct or tick yourself wrong. Why is this? When you tick yourself correct, there's this adrenaline pump that goes into your brain towards encourage you to do more. That motivates you as to, oh, you are getting well prepared for this examination. When you get it wrong and you introduce it there on your book, you can see it in ink and what? Paper, on ink and paper. It's easy for you to actually what? Draw in the consciousness of, oh, I have more work to do with regards to this topic. So the first one If you got it wrong, it only means that you've not been able to understand your principles quite well, involving Archimedes' principle, Pascal's principle, and also associating the law of flotation. Question 2. What is the relationship between the kinetic energy before collision and that after collision in an elastic collision? The kinetic energy before and after collision as far as an inelastic collision is involved. Now, here is the catch. You must understand that talking about collision theory, we always would say that elastic collision, in an elastic collision, momentum and kinetic energy is conserved. I come again. Under elastic collision, momentum and kinetic energy is conserved. As such, it's easy to say that what? Momentum before collision is equal to momentum after collision. Similarly, we can say kinetic energy before collision is equal to the kinetic energy after collision. But that will not apply under what? Inelastic collision. As such, we can say number 2 is this. Under inelastic collision, the following applies. We have that momentum before collision equals to momentum after collision. But with regards to kinetic energy, we easily say that what? Kinetic energy before collision is greater than kinetic energy after collision. Kinetic energy before collision is always greater than kinetic energy after collision. And why is that? Why would that be? It's simply because whenever you are calculating, remember what we have. We said that as far as momentum is concerned, m1u1 plus m2 u2 is equal to m1 plus m2 multiplied by a common velocity after collision. But here's the challenge here. You have here that when you want to calculate the kinetic energy on this part, we say half, remember kinetic energy falls under the concept of half mv square. So easily we say half m1 u1 square plus half m2 u2 square being equal to half m1 plus m2 v square. This happens to be the formula. You can test it out. Put in a value for m1, the mass 1, put in a value for m2, pick in the value for what? u1 and u2. Use it to arrive at the value for v. You discover that having calculated the common velocity, and you now try use it in this guy, you discover that the answer you are going to get here would not be equal to the answer on this other side. Rather, it is going to be greater than the value you are going to have on the other side. That is why when you have a car ram into a stationary truck, for example, you tend to have a complete destruction of the car, such that what? Some of the, what are they calling? Some of the momentum, some of the kinetic energy is lost in the process. It is lost in the process. You have that what? The kinetic energy each of them might possess before collision would certainly be different from what you are going to have after colliding. Why? It is expected that both of them are going to move at the same pace now. So one will be moving subject to the pace of the other, or both of them would come to rest as the case is. So there you have it with question 2. I'm sure you got it. Or I'm sure you were in the process of getting it. Question 3, what is the formula for frictional force in an inclined plane? I know many of you are already familiar with what the formula is as far as talking about the normal horizontal surfaces. Now, everyone agrees that frictional force Fr is equal to mu r, where we are having our r as the normal reaction. That is coefficient of friction multiplied by normal reaction. But you must wake up to the call that what? For horizontal surfaces, R is actually equal to just mg, mass times what? Acceleration due to gravity under horizontal surfaces. But whenever you are making reference to what? Inclined planes, there's an angle involved such that we have R to be equal to what? Mg cos theta. So what is expected of you to note is that what? For inclined plane, Fr for inclined plane is equal to mu r, which translates to Fr being equal to mu mg cos theta, instead of just mu mg that you're going to have for horizontal surfaces. You'll be having Fr being equal to mu mg cos theta, coefficient of friction multiplied by mass and acceleration due to gravity, then the angle, cos value of the angle to the horizontal. So now you have a clear distinction as to what your frictional force can be. Only two forms. Your frictional force will exist in two forms. The first part, mu r, where r is mg, or you have your r being equal to what? Mg cos theta. And mg cos theta will apply for what? For your inclined plane. Last, under mechanics, what is the formula for velocity ratio for an inclined plane? As far as an inclined plane is concerned, what will you attribute the velocity ratio to be? We say that velocity ratio would easily be equal to for an inclined plane will simply be equal to VR will be equal to VR inclined is equal to 1 over sine theta, or equal to distance of your effort over distance moved by load. 1 over sine theta, or you are working with distance moved by effort divided by distance moved by load. Remember that what for your inclined plane, this is what we have. You have an angle here. It takes effort to move a load up an inclined plane. So this is the effort distance. When this load gets up to the extreme height, it's easy to just drop it down. As such, we define this as the load distance. Distance moved by the load. So whenever you are placing the effort distance on top of load distance, we attribute it to what? Velocity ratio of an inclined plane. So ask yourself, what have you been able to score over 4? Talking about mechanics. How much of the topics do you actually know very well? Do you actually understand very well? So evaluate yourself. Over 4, what have you scored? Now, don't feel bad. We still have 4 more branches to look at. We've just looked at one of the branches, which is what? Mechanics. 4 questions under mechanics. Let's go to the next aspect involving heat and temperature. But don't forget, you've scored yourself over 4, what you have here. Let's look at heat and temperature. Are you ready? Let's go for it. Heat and temperature. Very interesting aspect of physics, whereby much is actually left in terms of the marks you can garner. Here we go. Question 1 under heat and temperature. So under heat and temperature, The first would be this, to test your readiness. We have this. At what temperature, is Celsius scale equal to Fahrenheit scale? So if you know it, maybe you've solved it before, just indicate the answer. If you've not, you can try see what you can manipulate around to get the answer. At what temperature is Celsius scale equal to Fahrenheit scale? These are basic questions that would help propel you into solving questions that has to do with temperature conversion. This is actually to test your understanding of how best you are good at understanding temperature conversion. When you are converting from one scale to another scale, remember we said we have multiple types of scale. You get to hear pressure scale, resistance scale, the resistance, you have volume scale, you have a faulty thermometer given to you in your examinations. Different, name it. So in this instance now, when you are comparing Celsius scale with Fahrenheit scale, what is going to be the temperature at which these guys will be equal? I'm sure you've written the answer. I'm sure you've calculated what you want to calculate. We get to look at question 2. Question 2. Question 2. Now, in the concept of things, you might have heard of the word anomalous expansion before. And we say anomalous expansion will be tagged the abnormal behavior of water. The abnormal behavior of water. Anomalous is actually the modified touch physics word being used. Abnormal is the normal general layman English introduced for better understanding. So anomalous expansion of water, explaining the abnormal behavior of water. So in such case, what knowledge you have under this aspect is to be tested now. Under anomalous expansion of water, what happens to temperature, volume, and density after 4 degrees Celsius? So these are highlights of things you want to what? Lay emphasis on in terms of your readiness and preparedness for this examination. Under anomalous expansion of water, what actually happens to temperature, volume, and density after 4 degrees Celsius? Indicates that anomalous expansion of water. The next, draw a relationship. You are not drawing diagrams anyway. You are just trying to write something that relates them, whether in form of the variation. Okay, is one varying directly, relating directly with the other? Is one relating inversely? Is one relating jointly? Is one relating partially? So, in what way do they relate? Draw a relationship between superficial expansivity and cubic expansivity. So let's see what your knowledge of expansivity is all about. Those formulas you have decided to cram from page to page, how best can you put it to good use if the questions given to you are actually what? Non-calculation questions, as the case is. When you get to see 40 questions in your UTME exam and you're seeing that like 25 to 30 are actually non-calculation questions, but they're technically constructed questions that require you to think. What happens in this case, whereby you cram the formula, and here we go. It's not about what formula you cram that is requested of you now. It is the test of your understanding of the topic that is put to test. So question 3, Draw a relationship between superficial expansivity